Hello everybody, welcome back to another video. So here we're going to go through a complete walkthrough of the paper 3HR this time, and this is from the same Maths A higher tier, and this came all the way from the January 2018 version. So without further ado, let's jump straight in then. So as usual, you always need to have a ruler measured in centimeters and millimeters, a protractor, compass, and a pen, preferably black pen, I believe. Yep, use black ink or ballpoint pen, a pencil, rubber, calculator, and maybe tracing paper, but usually you don't really need this. That's fine. Anyway, let's go right in, guys. As usual, the formulas we need to know, so you need to make sure you're up to date with your Pythagoras, trigonometry. You need to know your cone formulas, especially that the diagonal length L is actually a representation of Pythagoras' theorem with h squared plus r squared equals L squared. So look on the left if you want to find L. You got your sphere formulas, typical triangles, which has your sine, cosine, and area of a triangle. And yeah, just other useful formulas here. But to me, the most important ones which you're going to use at least frequently would be the quadratic formula. So make sure you guys got this nailed down, yeah? There's a volume for a cylinder here which is actually similar to a cone, except a cone is 1/3 of the cylinder of the volume. So look at the formula and notice that the cone is 1/3 of it. But anyway, let's go right into it, guys, yeah? So here we got 23 questions to break down, so let's do this. Okay, first things first, number 1. Expand and simplify the following expression. Okay, this is dead easy as usual. So you got the first bracket, 5 times x plus y, so just distribute it. So you're going to have 5x plus 5y. Just copy the rest, minus 3x plus 3y, and tidy up. So you got 5x minus 3x, which is a nice 2x. 5y plus 3y is 8y. Alright, hopefully I did not get that wrong. Now, let's move on to the next two. Actually, this is a very good question 1, very easy in fact. You guys are going to love it. So simplify t cubed times t7. So when you're timesing terms of the same base, you just add up the powers. So this would be 3 plus 7, which is 10. So t to the power of 10. Now simplify this one. This means that there are 3 lots of m to the power 4. So you can think of it as 4 lots of 3, which is 12. So 4 times 3. So m equals, so it'll be m to the power of 12. 4 times 3. Right, easy. Now, ABCD is a parallelogram, meaning we got some parallel sides from these two and 2 other parallel sides. They also tell us that angle DCB is 124 degrees, and E is on the point DC, such that AE equals DE. Ooh, looks like we got isosceles triangle. So it's telling us that this length here, and yeah, they mark it with this line here, is equal to this length over here. If that's the case, this instantly tells us that these angles here are the same, because in every isosceles triangle, if 2 lengths are the same, this means their respective angles are the same. So whatever this one is, because this one's labeled x, let's just call this one y to represent the same, yeah? Alright, so here, work out the value of x. Right, so let's do this thing. So, what do we know so far? So we got 124 degrees here. We can work out this angle here instantly, because the shape of this is known as an allied angle, because you go think of it as a C shape or a U shape. So this means that if this was, let's say, B, this would be 124 plus this angle would give us 180 at B, yeah? So we could say 124 plus B must be equal to 180. So therefore, B must be 180 take away 124, and that should give us 56. So that's the first bit done, so I can rub this out, call this 56 degrees. And the good thing about this problem is that when you got parallelograms, the corners are the same. So this corner C, 124 degrees, equal to the total angle here. Once we work out, 56 is equal to this one. So we can say y is 56. So we can instantly replace both these angles by 56. Now we can also say this. So because we know these angles, we can instantly work out the angle here, because we know the angles in a triangle add up to 180. So let's work out. So we can say 56, let's call this one E. So 2 56s, so 56 plus 56 plus E must be 180. So adding these two, you should get 112, and then subtracting it from 180, you should get 68 degrees. So this angle here is 68. And now finally, in order to find x, we can say that the angles of E and x, or 60A and x, must add up to 180 because angles in a straight line add up to 180. So over here, so let me just get my pen. Where's my pen? Okay, so 68 plus x equals 180. So just subtract 180, 68 from 180. 68, and you should get 112. And that's it, guys. This is the end of the question. So this should be 112 degrees. Okay, so just write it here in your final box, and let's move on. Okay, so number 3, so exchange rates. Okay, this is gonna be easy. So Faisal lives in the USA. He wants to buy one cotton sheet. Oh, in the USA, one sheet costs $79. Faisal knows that the same type of sheet costs 210 Egyptian pounds in Egypt, and these are the given exchange rates. And it's measured from euros to dollars and euros to pound, Egyptian pounds. Now, they want us to find out how much cheaper is the cost of one cotton sheet when bought in Egypt than when bought in USA. Give your answers in US dollars, correct in US dollar. Okay, so first things first, this one, the USA one is already solved because they already got in dollars. So what we need to do is convert the 210 Egyptian pounds into dollars by following this table. Now the cool thing is that when you're going from a certain element, you need to figure out if you're timesing or dividing by these quantities. Because we need to go from Egyptian pounds to euros, and then euros to dollars, we need to either divide and times. So let's do this trick. If you're going from a bigger value to a smaller value, you're gonna divide the quantity. Yeah. So firstly, divide 9.72. If you're going from euros 1 to 110, you need to multiply by 110, and that's it. Makes sense because dividing by itself will give us 1, and multiplying by 1.10 will give us, well, the answer. So in your calculator, write 210 divided by 9.72. 9.72. So I'll write the steps here as well. So 210 divided by 9.72, and this should give us. You could leave it as a fraction actually. In my calculator, I got 1750 over 81, and then this answer, whatever your answer is, multiply it by 1.10, and then round it up, and I got, let's see, 23 euros and $23.77. Oh my god, that is cheap. Wow. Okay, I didn't expect it to be that cheap, but damn, that is cheap. So this would be the dollar equivalent. So quick recap, just reduce it and then multiply by this factor. You know what? It actually makes sense. It makes sense because the Egyptian pound is almost 10 times its value. So you're looking at about 10 times smaller, and yeah, you can see that. So I agree with these results. They seem okay. So by how much cheaper is the cost of one sheet? Now we want to find the difference, yeah? So what you want to do is use your answer and subtract it from $79 because we're not actually done yet. 55.23, yep. So the difference is $55.23. Not bad at all. Big difference. Okay, let's move on. Okay, number 4, guys. So this is going to be dead easy. So on the grid, draw the graph of y equals 4x plus 2 for the values of x from these range. Now the easy way to do this is to simply just use the smallest value and the biggest and plug in and then connect the line, because this is a linear equation because it's written in the form of a single x and a constant. If those x squares or x cubed, then it'll be a curve. So this is a standard straight line equation. Now in your calculator, let's go ahead and plug in these points, yeah? So let's go do this thing. So oops, let me pick my pen. I'm gonna change it to red this time. So plug in -2 and 3. So you can say when x equals -2, y equals 4 times -2 plus 2. So replace x with -2. And when you do that, you should get -8 plus 2, which is -6. So the first coordinate is from x and y would be -2 and -6. Easy. So let's go ahead and do the same thing. So plug in when x is 3, what do we get? So we get y equals 4 times 3 plus 2, and 4 times 3 is 12, plus 2 is 14. So the final one's going to be 3 and 14. Yeah, that's really all you got to do. And now all you want to do is literally just smash all this in. So minus 2 and 6. Let's go ahead and plot that in. So first we go minus 2 and down to 6. Minus 6. Put x there. And lastly, go to 3 and go all the way up to 14. Now, as usual, I won't... Oh, actually, I can fit this in. Usually, the graph is quite big, but in this case, I can. And I don't actually have a ruler here, so make sure you use a ruler for this question, yeah? And connect the line. So just, I don't know, just try and hope like it connects something like this, yeah? The ruler should look a bit like this, so have a go and see what you'll get, yeah? And let me know. Right, number 5, guys. So here we go. So here is a trapezium and a square, all right? So let's just take our time to visualize them. So the lengths of the parallel sides of the trapezium are 24 and 30. The height of the trapezium is 12. The area of the square is equal to the area of the trapezium. So let's just write that down, yeah? So these have equal areas, okay? Okay. Work out the perimeter of the square. All right, easy. So one thing we need to know about perimeter of a square is because it's a square, all the sides are equal. So if we just call this one, I don't know, x, 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 this means that all of this is 4x. But anyway, that's fine. Once we find the area, you can just divide it by 4 to get the length of one side. And then just add it and then multiply it by 4. Anyway, first things first, let's find out what the area of the trapezium so we can equate to the area of a square. Now, the general form for a trapezium is actually given in the back. It's always going to be half times the average between 24 and 30 because you have to add up both lengths and take like the average of them. So 24 plus 30, that's exactly here, the average of them, times the height, which is 12. Easy. So the average of these two is going to be 27 times 12. So just have a go, just smash this in your calculator and see what you get. 24 plus 30 times 12. And you should get 324. So this is actually the area so far of the trapezium, and it's also the area of the square. So now, to find the length of a square, you could just square root the result. Why? Because we know that area of a square is x times x, yeah? It's base times height. So we can say area of the square be base times height. So squaring this answer, we should get 18. So this means that each length is 18. So let me write here, each side is 18. So the perimeter is going to be 4 lots of 18. So times that by 4, you should get 72 centimeters. Easy. All right, here we go. So number 6. So here is a field in the shape of a circle. Okay, so it looks like we got a standard circle with a line cutting through, and this would be the diameter since it cuts through the center and it has a length of 80. This means if we had to find the radius is always half the diameter. So let's just write it down, yeah? So radius is half diameter, which is 40. That's cool. Now let's check out what they actually want us to do. So the field is crossed by a path AB, where the AB is diameter as we know. Now angle runs once around the circumference of the circle. So let's just take note of that. Angle runs once. And since the circumference of a circle, the general formula is 2 pi r, and we know the radius is 40, he runs 2 pi r, so this should give us 80 pi. If you put this in the calculator, 2 times pi times r. Okay, that's done. Sachin, another guy, runs along the path from A to B and then runs back to A. So it seems like he's doing 2 lengths. A to B is 80 and then B to A is another 80. So he runs a total of 160 because 80 plus 80 is 160. Anil runs further than Sachin. So the first guy runs further than the second. By how much further? Give your answer in meters. Alright, this is fine. So we already found how long they both run. So Anil ran 80 pi and Sachin ran 160. In your calculator, just type the difference from 80 pi and 160. And you should get an answer and then round it up. So 80 pi minus 160, you should get 91.3 meters difference. That's it. Bravo, guys. Okay, number 7. So Ahmed bought 1 box of lemons. These boxes cost $4 and there were 24 lemons in that box. Now he sold 3/4 of all the lemons he bought for 30 cents each. So let's just stop there for a second. Seems to be a lot of information. He sold 3/4 of all the lemons. So that means we can find 3/4 of the lemons and find out how much he bought for each one. So firstly, 3/4 of 24. So you can write 3/4 times 24. Off means times. And you should get 18 lemons. That means for each lemon he bought for 30 cents each, we can multiply this by 30. So 18 times 30 cents. That means he got 540 cents or $5.40. Okay, in total. That's already bigger than the box. He then sold the rest of the lemons. So the rest means the remainder, which is, if there's 3/4, the remainder must be 1/4 for 20 cents each. So 1/4 of 24 would give us, well, 6. And he sold the rest for 20 cents each. So we can just say 20 cents times 6 lemons. Well, that should give us 120 cents or $1.20. Calculate the percentage profit that Ahmed made. So firstly, how much did he sell it for in total? Okay, he sold it for 540 plus 120 every single lemon, which is quite nice. So the total sold was 540 plus 120, so it should be $6.60. Not bad. Now to calculate the profit, it's always this. You could use it personally I use this formula. I always stick to the original value times 1 plus or minus the rate. In this case it'd be plus because our new value is going to be 660. So it'll be original value, which is always going to be how much he bought it for. He bought it for $4. Now we want to find the profit. So the R represents the profit. So let's call that profit. And it must equal to 6.60. Now just do some little quick maths here. So firstly, divide 4 across. So you're going to have 1 plus the profit equals 660 divided by 4. You know, you can just write here because everything is on a calculator. And then subtract your answer by 1 to calculate the exact profit percentage. So 660 divided by 4 minus 1 will give us exactly 65% profit. Not bad. So he made a profit of 65% from the $4. That is quite good. And that is really good. Okay, anyway, let's move on here to number 8. Okay, so the scale of a map is 1 to 50,000 units. So that means that every 1 unit on the map, that represents 50,000 units in real life. Now the length of the road on the map is 30 centimeters. Work out the length of the real road. Okay, so let's work at this before giving you answers in kilometers. So if 1 unit was 30, that means for the real world version, you need to multiply by 50,000. So let's calculate this. 30 times 50,000, what does it give us? 50,000. So that gave me 1.5 million. So 1,500,000 centimeters. That's kind of big. Now we want to put this in kilometers. So there's an easy trick. To go from centimeters to meters, firstly, C actually means 100 in French and Latin. So you need to divide by 100 first. Now to go to kilometers, you need to divide by 1,000, because kilometers is 1,000 times smaller, or it's 1,000 times. You can think of one kilometer as 1,000 meters, so it seems to be 1,000 times in scale factor. So yeah, that's what you do. So put this on using your answer in the calculator. Just divide it by 100 first, then divide the answer by 1,000, and you should get 15 kilometers. So the actual answer is 15 kilometers, and yes, that is 1.5 million centimeters. Yeah, sweet. Let's move on. Okay, number 9. So there are 320 students at school. So far, there's lots of fractions here, isn't there? And they all seem pretty straightforward. So 5/8 of these students are girls. Okay, so as usual, let's just work out 5/8 of 320. So in your calculator, 5/8 times 320. And this means there were exactly 200 girls, yeah? So 200 girls. And if you just want to make it easy for yourself, if there's 200 girls, meaning there's going to be about 120 boys, because 320 minus 200 is 120 boys. I mean, that's so far in 2018. Might change. Now, 3/4 of these girls have blue eyes. So let's find 3/4 of 200. So in your calculator, 3/4 times 200 should give us 150 girls. This means, yep, that's done. 2/3 of the boys have blue eyes. So 2/3 of your 120 boys have blue eyes. So in your calculator, again, 2/3 of 120 boys means exactly 80 boys have blue eyes. Okay, so these are blue eyes, yeah? BE, why not? Now, what fraction of the students at the school have blue eyes? Well, we can see altogether we have 150 and 80 boys and girls. So that's altogether, if you add them up, you should get 230 students that have blue eyes. And and we know there were exactly 320 students at the school. So this would be the fraction of students with blue eyes. Honestly, I think that's interesting because most people in the world have brown eyes, or at least from where I'm from. Anyway, put this in your calculator, see if you can simplify it, yeah? Well, I did, and honestly, since 23 is a prime number, it's going to be 23 over 32. And that's it, guys. That should be your result. That was really easy. Okay, number 10. Ooh, set theory. Let's see. So you're given a set. So this is epsilon here is the universal set, meaning literally every possible element that exists so far in this question. So A takes part of it, takes just the even numbers, it seems, from 2 to 12, and B seems to take the 3 times tables. So it looks like 2 times tables and 3 times tables. List the members of the union between A and B. So union means every single element that's in both. Okay, that's all you do. Copy every element in both. You don't need to repeat the numbers because that's unnecessary. So what do we have? So firstly, we have 2. So just give a nice curly bracket. 3. Do numerical order. 4, 6, 8, 9, 10, and 12. Nice. C is a set with 4 members. All right. Now this is very. Now we need to just imagine those 4 members. Yeah. It tells us firstly that the intercept between A and C is nothing, meaning A and C have no elements in common. So it could be the odd numbers firstly. Now B and C also have nothing in common. So the odd numbers are not in it, and the other numbers like 13 are not in common. So we'll list the members of C. Okay, so if they're not in common, so this means if it's going to be even numbers, then it's possible these could be it. So 1, 3, 5, and then we're going to cross out what we don't have. This is from A, yeah? 9, 11, and 13. Now it tells us B and C have nothing in common, so that means C does not have any of these elements here, so we can cross this out instantly. So it doesn't have a 3, it won't have a 9, and yeah, I think that's it. That means C must be exactly, oh yeah, what else does it not have? Let me just double check. 3, 6, 9, 12. So it could have a 1, could have a 7 because it's not in both. Could actually have a 5 because that's not mentioned. 11 and 13. I think this is plausible. Yep, that's definitely plausible. So this is the possible set elements it could have. Unfortunately, oh no, what am I talking about? Ignore me. There is no 1 because it begins with 2. So yep, 5, 7, 11, 13 is your result. Okay, guys. So slight confusion by me, but hopefully it doesn't affect you. But yeah, it's always the elements in here. I don't know where I got 1 from. So 5, 7, 11, and 13 is your result. So let's write it down. And make sure you put a curly bracket, yeah? Okay. Number 11, guys. Let's go. So here is a right angle triangle. Okay, cool. So it looks like Pythagoras right off the bat. When you think right angle, think Pythagoras, trigonometry, everything. Okay, so one length seems to be 10, and the long hypotenuse length is 20. Cool. And this seems to have equal lengths because, well, they're represented by two lines. So D is the midpoint of BC, so it makes sense. Has to be the same now. Work out the length of AD. Okay, alright, so let's break this down to 2 parts. Firstly, you got a Pythagoras theorem type question for the whole triangle. So let's take the whole triangle right now from ABC. So ABC. We know one length is 10, the other one's 20, meaning we can use Pythagoras theorem to find this side. That is a squared plus b squared is c squared, yeah? So we can say using Pythagoras, a squared would be 10 squared plus x squared, and this must equal the hypotenuse c squared, which is 20 squared. Now just rearrange this, so we're going to have firstly x squared equals 20 squared minus 10 squared. Put this in the calculator, 20 squared minus 10 squared. You should get 300, and the square root of 300 should give us 10 root 3. Let's just keep it as a surge, yeah? 10 root 3. Or you can keep it as root 300. Both is fine, yeah? Now, since we know the whole length here, so the whole length here is 10 root 3. So that means if we're going to find one of these lengths, say BD, we can say half of 10 root 3 would be 5 root 3. So they're both 5 root 3s. Okay, now this makes our life easy. So work out the length of AD. So we want to find this length AD. Let's call it Y, yeah? So we have another Pythagoras theorem. We have lengths AB, ABD. So this is our triangle. Okay, so let's pull it across here. I just want to pull it across here. So we go, firstly, one length is 10. The other is 5 root 3. And this one is Y. Now just use the formula, yeah? So Pythagoras theorem once again is going to be a squared plus b squared c squared. So it'll be 10 squared plus 5 root 3 all squared equals y squared. Okay, so 10 squared plus, and this is how you write it, 5 root 3, remember put in a bracket because you've got many terms, squared equals y squared. Okay, so go ahead and just put this in the calculator. So put 10 squared first, which is what we know is 100, plus, and then make sure you put this exactly in a bracket, 5 root 3 all squared. Okay, you should get exactly 175, so y squared is 175. That means square rooting this answer, and is 5 root 7, or to 1 dp, 13.2 centimeters. And that's it, guys. That's all you do, yeah? Okay, here we go, question 12. So here is a triangle ABC. So we're given the following triangle with some certain lengths. Now we know that DE is parallel to CB, and CB is 12 centimeters. Alright, so what we have here is basically similar triangles. You can think of ADE as a small triangle, and then the big shape A to C to B is the massive triangle. So they're just proportionally different. So what you want to always do these questions is always find what is the scale factor between them two. And the easiest way to do this is just look at the big one, for example, the one of common lengths. Here we got the long length is 12 from C to B, and the short length is 8. So in your calculator, just put 12 divided by 8 to find the scale factor. 12 over 8. And you should realize that the bigger triangle is 1.5 times bigger. So 1.5 times bigger than the smaller triangle. So here is our scale factor. So this would be the scale factor. Okay, cool. Now work out length of AC. So AC is going to be the long length here. So if the short length is 5 centimeters of the small triangle, that means the big triangle will be 5 times the scale factor. So it's going to be 5 times 1.5. So I can just do it up here actually. 5 times 1.5. And that should give you 7.5. So AC is 7.5. Work out now, it tells you that AB equals 13.5. So AB, so the long length from here all the way to here, it's 13.5. Work out EB. So work out the extra gap. So once again, we do the same thing. So we know that the long length here is 13.5. That means we could find the scale factor. Using scale factor, we can find the length of the smaller side, AE, and then subtract it from the big one to get the remainder, EB. So let's find AE. So AE is obviously going to be 1.5 times smaller than 13.5. So in your calculator, write 13.5 divided by 1.5. 13.5 divided by 1.5. And you should get 9. So now EB is just going to be the difference between these two. So we can say therefore EB is simply the difference between 9 and the whole one, 13.5. So it's going to be, if you take them away from each other, you should get 4.5. Yeah, so EB is 4.5 centimeters. That's it. Easy stuff. And here we go, number 13. So a train travels at a constant speed of v kilometers per hour. Now this train crosses a bridge, and we know that the length of the bridge is b, and the train itself is x. Okay, so let's start writing everything down. So the train travels at exactly v kilometers per hour, but notice how the measurements are in meters. And then on the next paragraph, it says t seconds is the time between the instant that the front of the train moves onto the bridge and the instant that the back of the train leaves the bridge. So the way I look at this, just picture this as a bridge. Okay, so t seconds is the time between the instant that the front of the train moves onto the bridge. Okay, so this is something we need to really establish. So onto the bridge. So this is literally where it's at, and this is the time we're measuring. From here would be the start of time 0. And the next bit, so, and this is the train. And the instant that the back of the train leaves the bridge, so the back of the train, notice how the back would be literally at the edge of the bridge here. So this is where the train is now, and here's the back. Okay. So we're going to measure from this point and literally the point where it leaves. So the back would be here, so meaning the train would have literally traveled the whole of the bridge B, and at the same time the train would actually have to move a little bit further X, because that's the length of the train itself across, meaning the end of the time point is here when the time ends at capital T. So this is the length of the time, T seconds. Now what else is happening here? So let's go back to the thing. So now all we do is represent this using our speed, time, and distance equation. But before that, let's rewrite this one in the same units of meters per second. So let's do that. So therefore, from the top here, the way this works, to change from kilometers to meters, we need to multiply V by 1,000, so it'll be 1,000 V. And to go from hours to seconds, well, we know that there's 60 minutes in an hour and also 60 seconds in a minute. So there's practically 60 times 60 seconds in an hour. So basically 1,000 over 60 times 60. And just to simplify this, because I noticed that the final answer wants us to find a formula for T in terms of B, X, and Y, and V, sorry, and in the simplest form. So smash 1,000 over 60 times 60 in your calculator and see what we get. So when I do that, 1,000 over 60 squared, I get 5 over 18 V. And this is now meters per second. So perfect. Okay, so let's go ahead and finish this off now, yeah? So we have all the components. We have the total. So yeah, so what do we want? So find a formula for T. So find a formula for time. That's what it means. So using the fact that speed equals distance over time, we can make T the subject. So we're going to have now time equals distance over speed. Now, what this means here, that time is represented by a capital T. The distance is going to be B plus X, the total distance. And the speed is going to be 5 over 18 V. Now, in order to simplify this, well, a quick way to do this is to multiply up and down by 18, so you clear out this little fraction here. So we're going to have 18 bracket B plus X over, and then 5 over 18V. So 18 cancels out the 18 bottom, so we're left with 5V. And there you have it, guys. This should be your final result. I believe that this is the answer they're actually looking for. Yeah, so if you got this, give yourself a pat on the back. And oh yeah, seconds. Can't forget the word seconds. Okay, number 14. So Andrew invests £3,000 in an account for 3 years at 2.4% compound interest per year. So before we continue this, just realize that this is our typical compound accumulation question. So we should always start like this. The formula is always going to be, firstly, the original value, which we're given, times some multiplier, so 1 plus or minus a rate. If it's going up, we use plus. If it's going down, like depreciating, we use minus. And then to the power n, which is the number of years, and this should always equal the new value. So from the first sentence alone, before I read the second, we can realize that we have an original, Andrew invests the original value of 3,000, and it's increasing at 2.4%, so it'll be positive 2.4%. And remember, you have a percent button in the calculator, so write exactly like this. Otherwise, if you can't find it, instead of 2.4%, use 0.024. That's the same thing. And then this goes on through 3 years. Now, if you put this in your calculator, you should get exactly £3,072. However, it says at the end of the 3 years, so now we're here, a deduction of 40% of the total interest is made from the account. Firstly, this is the interest component. The interest component is the extra amount added after the 3 years. We can see from 3,000 to 3,072, it's gone up by £72. So the interest component is £72. Now we need to deduct it by 40%. So using the same formula, the original value, so let's say 72, it decreases by 1 minus also 1 minus 40%. And because there's no years involved, we ignore that. And this should equal the new value after the deduction. Doing this, you should get, let me have a look, 1 minus 40%. You should get exactly 43 0.2 or 20. Okay, and that is the actual interest you're keeping. So this means that now work out the amount in the account at the end of 3 years after deduction has been made. So the total amount is obviously going to be the original you had 3,000 plus the new amount after deduction, £43.20. So 3,000 plus this amount should be £3,043.20 pence. Yeah, well done. That was an interesting question. I didn't realize you would have a deduction of interest rate, but looks like they're trying to spice it up now. So take your time with this one, pause this one and repeat this question and see if you get it a second time, 100%. Otherwise, let's move on. All right, simultaneous equations. I really love these kind of questions. So here we need to find the value x and y, and as usual, show our algebraic working. Now, what is the best way to do this? Well, as the first thing we want to observe is the fact that they're both linear equations. And to make life even easier, my personal resolve is always make the coefficients of x the same. In other words, the values of the number in front of x the same. So once we subtract these or add them, whatever, that at least they will disappear and we can solve for y. So let's have a look. So we got a typical 3x and 5y. The only way that 3x and 5x can be the same, or the lowest common multiple, is that if we multiply the first equation by 5, so then we're going to end up with a 15x, and multiply the second equation by 3, so we have a 15x as well, then we can move forward. So let's do this. So always multiply the top one by 5 to get 15, and this one by 3. Now we should have here exactly the whole set times by 5 should give us 15x minus 20y equals 40. The second equation times by 3 should give us 15x minus 6y equals 33. And that's it. Now, let me just change the color pen. Now all we do is literally look at them and subtract. So if we subtracted it, we'll know straight away that 15x will cancel out. And that is the point. The point is eliminate one variable and have just y or x left so we can actually solve it. You can never solve with two variables in a single equation. It's impossible. So subtracting this, so 15 take away 15x is nothing. 20 minus 20y minus 6y. So in your calculator, it's always best to look at it as minus, and then the double minus makes a plus. So minus 20 minus 6 is minus 20 plus 6. So minus 20 plus 6 gives us exactly minus 14y. Now finally, 40 take away 33 is 7. And there we have it. Now we just divide minus 14 across, and we should have y equals minus 7 over 14, or minus half. Easy. Now, all you have to do here is literally smash this into either one of these equations. I'm going to pick the second. Why? Because you got 2 in front, and the 2 and the 2 here will cancel out, so you just get 1. Now let's have a go and do that. So I'll use a blue pen this time. So now using the second equation, plugging in y equals minus half, we have 5x minus 2 times negative half equals 11. Expanding this out, we get 5x. Now minus 2 times minus half will give us a positive 1 equals 11. Take away 1, we get 10 on this side, and dividing by 5, we get 2. And that's it. So your solution pair will be 2 and minus half. Cool. Question 16, guys, and this one's all about cumulative frequency. So what do we have here? So it says that the cumulative frequency graph gives information about the cost on the x-axis in euros of the 120 holidays in Cyprus. And we can see that the final cumulative value would be for all 120 holidays, with the maximum cost being 1,200, and the minimum, if there was no holidays included, would be at 200. And it's always going to be increasing. So just one thing to note, cumulative frequency graphs are always increasing, because the more you increase the sample size and the more people add along the sample size, the higher chance of the width going up with it. So just think of it, it's always increasing, yeah? It's always a kind of smooth curve. Now, part A, find an estimate for the median cost. So median means the middle value. So if you got 120, it would be the 60th person, because that would be the median right value there, the middle point. So let me just circle 120. So half of 120 is 60. So we're just going to draw a dotted line across 60 and let it hit the curve. So just to be very careful, I think it hits around here, the middle value. So it should cut off around there. God, I hope I didn't make it too hard for myself. So, and I think that's, let's see. So It looks to me that halfway between is 700 and it's going up in 20s, and this is between 700 and 720, so I think it's 710. I'm going for 710, guys. See what you lot get. Find an estimate for the interquartile range. The interquartile range is the difference between the upper quartile and the lower quartile. So upper quartile is literally the third quarter of 120 of the all 120 holidays. So in your calculator, just type 3/4 of 120 and you should get 90. And 90 should be bang there because it seems to be going up in, let's see, you got 5 blocks to make 20. It seems to be going up in 4s. So that should be 90. So that means you should cut off around here. So this is the upper quartile value, yeah? So just draw like a nice, or use a ruler, yeah? So this is the upper quartile. And then just hit it downwards. So it should be on this line. So it should drag all the way up to here. And we can check that out. So that would be, oops, that should be about, let me think. So 900 is in the center. It's going up in 20s. So I want to go with an estimate of 880 here. Now the lower quartile would be 1/4 of 120, which is 30. So this is the first quarter, and it cuts around there, and it should be around there. So that's 500. So this is about 510. So we can call this one lower quartile. Yeah, and you can just add a name here. This was the median. So it's good to show your working out as well, just in case the exam needs to see and they just need to be confident that you got it right. Now, all you got to do to find interquartile range is just the difference between upper and lower. So in your calculator, 880, oops, minus 510. And you should get about 370 euros. So that's the range of values where the bulk of the people and where the bulk of the 50% people are lying in between. Now, the final thing, 15% of these holidays had a cost greater than N euros. So if we had 120, we're talking about the upper 15%, the final 15% on the curve. So in your calculator, find firstly how many holidays this includes by finding 15% of 120. So I'll write that down. So first, in your calculator, 15% of 120. So 15% times 120, and you should get 18. So we're talking about the last 18 holidays. And the last 18 from 120 means should be 102 onwards. So just double check 120 minus 18, meaning holidays from 102 onwards. So that's actually from here. So I'll write down here from 102 plus to 120. This includes the last 18 holidays. So what I'll do, I'll drag this line across, and it should cut around there. Perfect. So let me just mark an X there. And now we just go down. So this will tell us the value of n. So the n euros. So use the graph to find estimate for the value n. So the n value here, if we drag it all the way down, I think it's bang in center actually from here. This is 900. This would be about 950. Yeah. So the last expensive holidays, I don't know, maybe Dubai or something, will be 950 euros. Okay, good old algebra. So number 17, show that the fractions on the left hand side can equal the right hand side. So the aim is to look at both of these fractions and see if we can pretty much represent what's over here. Now, my advice is we need a 2x plus 1 and x plus 1 as part of the denominator. You see the second fraction already has it, but this one's missing the x plus 1. So all you want to do is just multiply up and down by x plus 1 and just whip out a bracket and you should be fine. So this means by doing that, we're going to therefore have on the top half x plus 1 times x plus 1 over what we need, 2x plus 1 times x plus 1. So now we've done it. So now we got exactly what we need. And now we just minus it against the second fraction. Minus 1 over 2x plus 1, x plus 1. And now since we have common denominators, now we can just subtract the top line. So our result is going to be x plus 1 times x plus 1 minus 1. And just to be obvious here, since if we solve this one, we should get this result x squared plus 2x. We could, but for the purpose of it, we need to show it step by step. So let's go ahead and combine the fraction now and then evaluate the top line. So over here, just the top, working from the top line only, so just doing the top line. If you expand this bracket, you need to use a Fourier method. So it'll be x times x, and then x times 1, and then 1 times x, and 1 times 1. So x times x is x squared, x times 1 is 1x, plus 1 times x is another 1x, so you get 2x, and then 1 times 1 is 1. And now it'll be all over the same thing. So now we subtract against the top half, so it'll be minus the other one over here, all over 2x plus 1 and x plus 1. Usually these kind of equations, you never solve the bottom, you just tidy the top half. And now we can clearly see that all we need to do is realize that we have 1 take away 1, which is 0, so we could just rub this out and we are done. And that's literally your result. Proved. Now be careful this part B, because look what it says. Hence, solve the same equation you did over here, so x plus 1 over 2x plus 1 minus 1 over 2x plus 1x plus 1. So basically this left hand side is identical to here. And we said show that this can be represented as x squared plus 2x. The point of this question is that when you have hence, instantly replace this with your result here. That's what they're saying. Now hence solve that this hand, the new equation you made, will equal the right side. And we just have to solve it. So we need to just remove the fraction, clear the fraction, and just do some algebra here. Okay, alright, so let's just warm up the question. So we can say firstly we have x squared plus 2x all over what they said equals 1 over 2x plus 1 over x plus 1. So that's the first step. Now, the smart thing to do is to firstly clear the fraction, because nobody likes working in fractions here. So clear fractions. And now we just multiply by the terms we need. So since we got 2x plus 1, x plus 1, we multiply both sides by that term. And doing so would actually cancel everything out. So we're left with just the top line. So now we've got x squared plus 2x equals 1. Rearrange this into the standard quadratic form. So x squared plus 2x minus 1 equals 0. And voila, practically done. And the good thing about this one, I think we actually opened it earlier. Now we didn't. So now we just factorize this one. So using the double bracket method, we can just put x on one bracket, x on the other. And we just need two numbers that multiply to make 1, which is, well, 1 and 1. 1 times 1 is 1. And these two numbers, you can add them to make 2. Well, in this case, let's have a look, trying to make plus 2x. Oh, my bad, you cannot do that, that's impossible. I just realized that this question wants you to use a quadratic formula because it gives you answer 3 significant figures. So they knew that this wasn't obvious. So using the quadratic formula, which is x equals minus b plus minus square root b squared minus 4ac over 2a. So just FYI, this is in the formula book, right at the top of the page. Now we can say that firstly, according to this expression here, a is 1 because of x squared, b is 2 because of 2x, and c is minus 1 because of the minus 1 term. Now go ahead and smash this in, guys, yeah? Be very careful with the minus b. If you got minus 2, for example, it would be positive 2, but because it's just a standard 2, minus b is minus 2. Plus minus, b squared is 2 times 2, which is 4, minus 4 times 1 times minus 1. Just put everything in. Okay, and now all of this, over 2a. So where's my pen? 2 times 1 is 2. Yeah. So just smash this in the calculator, guys, yeah? And just have a go. So remember, this says 4 minus 4, bracket 1, bracket minus 1. Always replace your letters with brackets if they're all glued together. Now, have a go. I'm going to do this myself. So minus 2 plus square root 4 minus 4 times 1 minus 1 2. Okay, I got a third, but converting it, I got firstly x equals 0.414 using the plus sign, and if I use the negative part, I should get minus 2.41. And give your solutions correct 3 significant figures. Yep, that's it. So this should be your final result. So just have a go with your quadratic formula, plug it in properly, and just smash it in the calculator. It should be fine. Alright, let's move on. Getting a bit tired, actually. Now, question 18. There are 4 white tiles and 3 grey tiles in a bag. So we can see 4 white tiles numbered 1 to 3 and 3 grey tiles 1 to 3. There are no other tiles in a bag. Cool. Flora takes at random a tile from the bag and she keeps the tile. Naughty. Esther then takes at random a tile from the bag. So after Flora takes one, keeps it, then Esther takes one. So it looks like a two case probability. Work out the probability that Flora takes a white tile and Esther takes a grey tile. Remember, when Flora takes it, she keeps it. So firstly, probability, so we write this out. Probability, white goes first, then grey goes second. In this order, yeah? So probability if Flora takes a white tile would be, firstly, there's 4 white tiles out of 7, so 4 over 7. Now she kept it. Meaning now, let's say she took this one, now there's 3 left. And probably Esther takes a grey tile, be 3 out of how many is left? Well, 6. And we're done. That's all you have to do, guys. So let me just put that in a calculator. Well, you can put this in a calculator if you want. So you just write as it is. 4 over 7 times 3 over 6. And you should get 2 7s. That's what I got. Really, probability is dead easy. Now, the numbers on the tile are taken from the bag are added together to get a total T. Work out the probability that T is 4. So we just need to find the sums of how to make 4 on these tiles. Well, we can see that we can make 4 using 1 and 3, or 3 and 1, and 2 and 2. That's really it. So we could say find the probability of getting firstly 1 first and 3, or probability getting 3 first and 1, and probability getting 2 first, then 2 again. So let's do the counting, yeah? So what's the chance of getting a 1 first? Well, to get 1 first, you have 2 options, so it'd be 2 7ths. And then to get 3, you have 2 options as well, but then she took 1, and you got 6 cards remaining, so it'd be 2 6. So remember, Esther always keeps the card she takes, so it always goes down to 6. So we can just write down the same for everything else, over 7 over 6. Now, what's the probability taking a 3 first? Well, again, there's 2 3s, so it'll be 2 7s. Esther keeps the card. And probability getting a 1, well, there's 2 1s, so it'll be 2 6. So again, identical probabilities at the top. And lastly, to get a 2 2. Probability getting a 2 first is, there's 3 2s actually. So it'll be 3 7s. She keeps the card. So now there's 2 left. So suppose she just took this 2. So now you've got 2 left. Now she got 2 6. That's it. So evaluate all probabilities so you can do it head on. So 2 times 2 is 4. 7 times 6 is 42. So everything's over 42, yeah? 2 times 2 is 4 here. 3 times 2 is 6. And now you just add them up. Because remember, you want to find the total mutually exclusive probabilities. Always add up the final result, yeah? So 4 over 42 plus 4 over 42 is 6. So 4 plus 4 is 8. 8 plus 6 is, my God, 14. So it'll be 14 out of 42. And that's it. And I think this is 1/3, right? Yep, 1/3. All right, circle geometry. I know how much you guys really don't enjoy this one, but let's try our best and smash this, yeah? So we're given a typical shape, and let's see what we can do before we solve the question. I always like to work this on this first. So one thing we can say, at point O, we can always deduce that the angle at the center of the circle is always twice at its circumference, which is over here, yeah? So it's always this kind of bat shape. So if this was 70, this is 78, so this would be literally 2 times 78. And that is, thank God for calculators, 156 degrees. So maybe I should write 156 first. Okay. That's good. That means you can actually work out the angle around it now. And over here, I'm going to assume this is a tangent because a tangent always hits a circle. When it hits a circle, it's always perpendicular to the center. And it says over here, this is always going to be flat 90 degrees. And anything else? Well, I think that's it for now. Oh yeah, and you go find the angle around here. So, you're given all the information we know. Work out the size of angle OBP. That's labeled out X. So OBP. So it's literally this thin angle here. This is OBP. Okay, all right. All right, you know, I guess we have everything already. This is kind of a four-sided shape, so we got this angle here. So we can say angle around the point over here adds up 360. We've got 156, so subtract it from 360 to get the angle around it. 360 minus 156, you should get 204 degrees. So this is 204 degrees. And now looking at the shape carefully, so I'm going to pull out here. 204 degrees. We have a right angle, we have 34. And we know that in a four-sided shape, this is four-sided if you count, it always adds up to 360. So we can just say, okay, 204 plus 90 plus 34 should give us some figure, and then we subtract it from 360. So I got 328 when I added all these up. Subtract it from 360. 360 minus your answer, and you should get 32. So x is 32 to make this whole shape 360. Voila. Question 20, histograms. And thank God, I was looking at this earlier, and this is actually dead easy, guys. Now, check this out. So the histogram gives information about the lengths in millimeters of 1,875 snails. That's a lot of free time to redo that, but nice, guys. Now, checking all this information out, the way we evaluate histograms is that I treat these as simple rectangles. For example, the frequency, the class width down here multiplied by its frequency density, the height, always gives the area inside, which represents the number of snails or frequency. So always draw this sketch when you start these questions. Call this side class width, frequency density, and then realize that the area inside is the frequency. So frequency equals FD times CW. Now, looking at, let's say, some of these examples, let's look at this very thin block. We can see that there's a width of 5. The value between 10 to 15 has a difference of 5, and it has a height of, let's say, 45. So you could say in your calculator, 5 times 45 should give us 225. So this block has 225. I'm guessing that's exactly the correct number of snails here. The frequency here represents, the total frequency should be 1875, add them all up. And we just repeat the rest. Now the question here tells us to calculate an estimate for the proportion of the snails more than 55. Now more than 55 implies we're looking at here, which is 55, the 55 mark. The area from that accumulates from here all the way to the right. Now this is easy because you just realize that this is just a small rectangle of length 5 and height 25. So here, this rectangle, I'll just label it, is 5 times 25, which is 125. And this rectangle here has a length of 30 and a frequency density height of 10. So 30 times 10 is 300. That means the total number is 125 plus 300. Let's write them down. And it should be 425 snails. And I believe that's it. That should be the final result. Okay, number 21. Whew. Let's take a breather, guys. Remember, you still got all the time in the world. So we got y equals 4ax squared and z equals a squared x cubed. Given that y equals 4a to power k z to power w, so some expression that involves a and z, find the value of w. So just double checking. W is this little power here, if you guys can see clearly, yeah? Is a power of z. Now all it seems to me is that they've just literally removed the x. So the key idea is to make x a subject for, let's say, one of these variables and plug in. It looks to me that they've copied out exactly the y equals 4a equation and then replaced x here with a z on the second. So this is actually a simultaneous equation, guys. Just got to plug in. So let's go ahead and do that, yeah? Let's say substitute the z equation into y equation. Okay, so to do that, we need to make x the subject first. Let's go ahead. So on the right hand side, we can say so what we could do, firstly, you need to get rid of the a squared. So divide a squared across. We can say therefore z over a squared must equal x cubed. And then we want to find an expression for x. So we can just the cube root, the solution. So we can say therefore the cube root of this one, instead of saying the cube root, we can just attach a power of a third, because that's the same thing as cube rooting. And cube rooting this one would be a to 2/3. And this should give us x. And now if you want to get the actual x squared expression, you can just square this now by multiplying these powers by 2 or attaching a squared. So we can say x squared is going to be literally attaching 2's in this one. It will be 2 times a third, which is 2/3. 2 times a to power 2/3 would be 4/3. That's it. Plug this back in and see what we get. So now we can say that therefore this equation here can be represented as y equals 4a, and x is now, let's have a look, z 2/3 of a 4/3, so sorry, x squared is this. And now just combine the power. So it looks like we need to make a single a, so combine these a's and a single z. Remember, this is a to the power 1 here because we're working in powers. So what do we have? So we got 4a to the power 1. So when you're dividing, you're subtracting powers here. So this is a to the power 1 divided by a to the power 4 thirds. So 1 minus 4 thirds. Just put that in your calculator. 1 minus 4 thirds. And you should get minus 1 third. So we now have, we combine the a's and call it a to the power minus a third. And z to the power of 2 thirds. And that's it. So that means the value of w, which is this part, is 2 thirds. And the value of k is minus 1 third, which is here. So that's 2 in 1. Right, let's move on to the next bit. So now it tells us that m equals 10 to the power 3. Capital N equals m times m to the power m. And just to make your life so much easier, combine these together. This is m to the power 1. When you times it, you can add the power. So it'll be m to the power 1 plus m. Oh god, that does not help. Write n in the form of 10 to the power n, where n is an integer. Oh my god, I can imagine you guys just getting sick of looking at this right now. All right, let's have a go. Yeah, let's take it easy. So replacing everything with what we know. Let's just have a careful look at this. And funny thing is they're both m's. Okay, so I'm gonna go back to the beginning. So m here is 10 to the power 3 times 10 to the power 3 times itself power, which is also 10 to the power 3. God, crazy. So let's evaluate this. Let's evaluate. Write n in the form of 10 to the power n to... You know what, let's see if you can smash this in the calculator. I wonder if you can actually do that. 10 to the power 3, because you can evaluate this, but if you can actually just plug it in, that would be so cool. 10 to the power 3 times 10 to the power 3. Nope, you get error. Okay, let's evaluate this. So, working the powers. Let's work with these powers here. So 10 to the power 3 here checks out. The second one here, let's multiply this power. So we've got 3 times 10 to the power 3. 10 to the power 3 here should give us 3 zeros basically. And that is equivalent to 1,000. So 1,000 times 3 is 3,000. Okay, so this one becomes 3,000. Now we just add the powers. So finally, if you multiply, add the power, so 3 plus 3,000 is 3,003. I hope I explained this well, guys. I admit, I was slightly baffled, but I understood it. And I hope you guys understood what's happening. All you do is pretty much collect the powers, tidy powers first, and just add them in the end. You know what? For all these questions so far, I realized that they're definitely significantly more difficult than the ones from compared to the older years and the 3H/4H versions. The 3HRs are definitely a step up above. So hopefully do this. I really recommend you do this paper. This will definitely improve your math skills significantly. Anyway, back to the question, yeah? Number 22. So here is a solid shape made from a cone and a hemisphere. Okay, so hemisphere is simply half a sphere. And we're given volume equations right in the beginning of the book. Now, let's check this out. The radius of the hemisphere is 3r, good. And the height of the cone is 4r, so that's usually h, but given this information. The volume of the solid shape is 330 pi centimeter cubed, so that's actually the total volume. So let's just stop there for a second. Let's go ahead and realize what are the individual volumes, because that's what they want us to do, I'm pretty sure. The volume of the cone, using the usual formula, is 1/3 times pi r squared height. It's 1/3 of a cylinder practically. Where the height is 4r and the radius here is 3r. It's kind of confusing with the same notation. Now the volume of this one here, of the hemisphere, is actually, well, we're given the volume of the sphere, which is 4/3 pi r cubed, and because it's half of it, it's going to be 2/3 pi r cubed. This is half of a volume of a regular sphere, yeah? And the radius here will be 3r. So updating this, so remember this is the general formula. Using the correct formulation, we can say now that the height here is actually 4r and the real radius is 3r. So now the volume of the cone will be 1/3 times pi, the radius being 3r squared, and the height being 4r. Likewise, for the hemisphere, the volume is going to be 2/3 pi, and then the actual true radius is 3r cubed. And that's it. And then, of course, since we know that the volume of the total shape is 330, if we add up the total result, we must get 330 pi. That's a fact. Now, what does it want to do? Find the value of r in the form the cube root of n. Your n is integer. Ooh. Not so friendly with these with these exact expressions. So key idea is to add these up and then solve it in terms of this equation. So let's just have a go right now, yeah. So using the first equation, we could say therefore that the volume for a cone plus the hemisphere must equal 330. So let's write down. So 1/3, and I'll simplify this as we go. 3r squared will give us 9r squared, and then 9r squared times 4r. So 9 times 4 would give us 36, and then r squared times r give us r cubed, plus 2/3 pi. Okay, let me just write the whole thing out. 2/3 of pi times, and now 3r cubed will give us, 3 cubed is 27, and r cubed is r cubed. And this must equal 330 pi. So here we go. So these are the two volumes. Must give you the total volume of the shape. Now you just solve it, make R the subject. Okay, so let's check this out. So first thing to know, the cool thing about these equations, because you have pi everywhere in every part, you can just cancel pi out. Divide everything by pi and all the pi's cancel out, because there's pi's attached everywhere. Now, I will tidy this up. 1/3 of 36 is 12, so this is 12r cubed. Over here, 2/3 of 27, so I can't be bothered to work this out. This should give us 18 in the calculator, so 18r cubed must equal 330. Now the math is easy. 12r cubed plus 18r cubed will give us 30r cubes equals 330. Divided by by 30, so you know, I love the fact we have a calculator. 330 divided by 30, it should give us 11 in your calculator. And finally, you can say the cube root of this value will be this. Done. Actually, this was a lot easier than I expected it to be. Yeah, that's it. Complete 5 marks for this. Hopefully, again, I didn't make a mistake. If I did, check it out and let me know what you also got, yeah? 3r squared, so you should get 9 times 4, 36. And that's it. Let's move on. Oh my god, guys, I can't believe it. Finally, the final question is finally here. So number 23. So it says f is a function such that fx equals x plus 1 all squared for positive values of x. Find the value a for which the function at point A is 25/9. Show clear algebraic working. Okay, so this literally means that you just plug in the value of a, replace all the x values of a, and equate it to, well, where it wants, 25/9. Let's do that. So we can say at x equals a, like it suggests, this entire function a plus 1 squared must be equal to 25/9. Yeah, and now we just solve it. So first things first, square root. So you're going to have a plus 1 equals the square root of this side. So, oh, this is easy. Should get 5/3. It's going to be positive because x is positive, it says. And then, yeah, and then you just subtract 1. So a, subtract 1, you get 2/3. Done. Yeah, I was just feeling a bit tired, that's all, guys. But when you do this, it should be alright. Yeah, just 2 more parts to go, guys. So g is the function such that gx equals 1/x for positive values x. Show that x squared times fgx equals fx for all x values positive. Damn. So what this really means, firstly, we find the composite function fgx. So when g enters f, so when 1/x enters this function of fx, where x is now 1/x literally, and then you multiply by x squared, and you should get where the original fx representation. So let's take in parts here. So let's just work with this part here. So first we have x squared, that's done. Now fgx. So let's replace the x value of fx with 1/x. Let's smash 1/x into here. So this would now become 1/x plus 1 squared. 1/x plus 1 squared. Let's see if we actually get fx, yeah? Because it says show that, not solve. So what happens here? So let's expand the bracket here. So let's leave x squared outside. Now, if you realize that this is just simply double brackets, this is the same as x squared times 1/x plus 1, and then again another 1 over x plus 1, and then we use FOIL. We can say 1 over x times 1 over x is 1 over x squared. 1 over x times 1 is 1 over x. 1 times 1 over x is another 1 over x. And lastly, 1 times 1 is 1. Now we just expand the bracket. So let's remember, so this is our equation here. Oops, I'm going to use red. So x squared times 1 over x squared will just give us 1. X squared times 1 over x gives us plus x. X squared over x cancels out the x. X squared times 1 over x will give us another x, so that's actually 2x. X squared times 1 will give us plus x squared. So actually tidying this up, you get x squared plus 2x plus 1. And how do we show this that this is fx? Well, fx is factorized. So, and thankfully this is easy to factorize. Get a double bracket out. X and x. Two numbers times to get 1 is obviously 1. And add both, well, to get 2. And then you can rewrite this as therefore x plus 1 squared. And this is fx. Done. Only for 2 marks, really? that's really brutal. So it says here h is the function such that h of f(x) equals x for all x values greater than 1. So this means that we have a new composite function where f enters h. Find the individual function h when separate in the form hx. So we just got to partition these. So there's a trick here. The idea is to look at this function and realize that we can invert this. We can pretty much see how we use sine x equals some number. We can put sine other side by inverting the sign. So it'll be sine 5. Okay, that's fake. But 1/5, for example. We can do the same with h. We can invert the h across. So that's the technique. And then isolate fx from it. So hold on. Let me just tie this up. It's going to look a bit weird, but this should be fine. Let me just make more space, guys, here. But come on, Roboy. You know, it doesn't matter. We'll just work with blue. So we could say using the original function, if we invert h across, we should now therefore have fx on the left and the h inverse on the right of x, which is perfect because if you actually invert this again, you're going to get the real h function. But the key idea now is to replace fx with what we know. We know that's x plus 1 squared. So we can say that x plus 1 squared must equal the inverse. And now using the general inverse rule where we can just say let y equal this and then invert the letters, we can resubstitute it, we can resolve it in terms of y and boom, we have it. So you can just say let y equal x plus 1 squared, invert the letters so you have x equals y plus 1 squared, make y the subject, and then you have your function, your original inverted of the inverse h, which is the regular h. God, let's have a look. So what we could do is square root both sides. We're going to have root x equals y plus 1 and then minus 1. So we're going to have now y equals root x minus 1, and that is our function, root x minus 1. Done. Well, I'm beat. I'm really beat, guys, and I'm glad you watched this video. You know, just to get this, if you enjoyed this, let me know. If there's any questions you wish to discuss, again, just write in the comment below and let me know. Just send me the question, state the number, and I will try to help you as soon as I can. And hopefully discuss among each other as well. Maybe you guys have slightly different results for any questions. Just remember, there's no mark scheme, so these are pure model answers. But hopefully most of it is as accurate as possible. But anyway, thank you so much for watching. I hope this has helped in your studies, and I shall see you in the next ones. Ciao.